Okay, we are moving into Chapter 9. Looks like I forgot to put your name and date at the top. So get your name and date somewhere up at the top of this, and in case we forget it. Okay, so this chapter is called Scatter Plots and Data Analysis. So really we're just working with data in this chapter. This first one is called Scatter Plots, so scatter all over. The table below, or the table shows temperatures in degrees Celsius and the corresponding temperatures in Fahrenheit from a local weather station. Graph the ordered pairs, C going first, then Fahrenheit, Celsius and Fahrenheit, is the slope of the line passing through the points, positive or negative. So if we have Celsius at 0 degrees, then the Fahrenheit would be 32, 5 and 41, kind of estimating here, 10 and 50, 15 and 59, 20 and 68, so hopefully we could actually stop here if we kept going, but it says, is the slope of the line passing through the points positive or negative? So it looks like a pretty straight line. In fact, it is a straight line, and this would be a positive slope. There's actually a formula to convert those. If you're interested, I'll tell you later. Grab your vocab sheet. We have 2 vocab words here. Data with 2 variables, or pairs of numerical observation, like Celsius versus Fahrenheit, are called bivariate data. So bi means 2. A scatter plot shows the relationship between bivariate data graphed as ordered pairs on the coordinate plane. And sometimes there's a lot, and sometimes there's a little. For example, the bivariate data set, year and number of visitors, can be displayed as a scatter plot. So we would see that just like Celsius versus Fahrenheit. This one has eruption duration, so how long it lasted at Old Faithful, and the waiting time between. So 2 different types of data. This was the temperature and the amount of people, their sales. So as it got hotter, the sales of ice cream went up. This one doesn't really, it looks like a positive association, but not a lot of clear cut. So, making scatter plots. Construct a scatter plot of the weight of an alligator at various times after hatching. So what makes sense to go down here? Weeks or weight? Because this one depends. This one depends on this one. So does the week depend on the weight, or the weight depend on the week? The weight depends on the week. So this is my X. Here is my Y. This is in pounds. I'm going to abbreviate. So at week 0, an alligator weighs about 6 pounds. 0.6. At 9 weeks, there's an 8.6. Now, if you can kind of make a prediction, as the alligator gets older, what's going to happen? 18 and 10, 27 and 13.6, 34 and 15, 43 and 17.2, 49, it's almost a year old, and what's less than 20 pounds? It surprises me. So we've created a scatter plot. Doesn't necessarily mean it's going to be a perfect line, but they're kind of up and down, and that's okay. So it's no lines, just plotting the dots. Okay, well there are different ways that the lines, if we were to draw one, are related, or how the points are related to one another. So we have something called variable association and linear association. We're going to pick one from each category in the coming up here. So we have a positive association, so it looks like if we were to draw a line going up, negative association, or it's all over the place, so there's no association. Does it create a line or not? So linear would be line or not. So this one looks like we could put a line in there and it would go through most of those points. This one looks like if I tried to put a line there, it would miss them. If I tried to put a line there, it would miss them. This one looks more like a curve. So this would be nonlinear versus linear. Okay, so a lot of information here. There's also things called outliers and clusters. So you can analyze the shape of the distribution of a scatter plot, which is just the way it looks on the graph, to investigate patterns of association. If the distribution shows a positive or negative association, then the distribution can be classified as linear or nonlinear. We just talked about that. The scatter plot below shows a positive linear, the scatter plot below shows a positive nonlinear because it goes up, but it's curving Clusters or outliers can also be identified. So maybe if this were talking about temperature versus ice cream sales, this would be your hotter temperatures, and as temperatures, or these would be your cooler temperatures. Now this doesn't make sense for that, so don't, just scratch what I said. But this has an outlier, which is a dot way off the beaten path, and a lot of things happening at the lower number, so that would be a cluster. So now using all of that to identify some of these. So interpret the scatter plot of the data for the amount of memory in an MP3 player and the cost based on the shape of the distribution. Or you could replace that with phone or iPod or something. So variable association. So basically, is this positive, negative, or none? And it looks like these dots are going up. So this is a positive association. Could we put a line through here and get through the majority of the points? Or do those points kind of follow along that line? And the answer is yes. So this is a linear. And other patterns. Do you see any major clusters or major outliers? And I would say no, no major clusters. Not as obvious as this one, or an outlier as obvious as that one. So if we don't see any, it is okay to write none. Okay, so those are the three things you're going to be looking for. And other patterns would be outliers or clusters. That's what you would identify there. So in this one, interpret the scatter plot. This also means that the more memory it has, the cost goes up. That makes sense. Interpret the scatter plot of the data for 2 weeks in May and the amount of ice cream sold at a shop based on the distribution. So does this look positive, negative, none? I would say there's none, no association. It's just 2 weeks in May. May is pretty warm, so their sales can go up or down. Linear, I don't think there's a line that can go in there, so non-linear. Clusters or outliers? I don't really see any. Not major. They should be major. So I would say no, none. Okay. And letter D. So it says, interpret the scatter plot shown for the men's Olympic 100-meter freestyle swim winning times. So as the years get older, or as time passes, the winning time in seconds goes down. So really, the faster they get. Okay. So variable association: positive, negative, or none. Let's say this is going down. So it'd be negative. Is there a line that we could roughly put in there? I would say yes. Linear. Other patterns, so outliers or clusters. I don't really see any outliers or clusters. An outlier would be like way out here, or a big cluster. So I'd say none there. Prediction for 2016. So this is going to be a guess, but these are going up by 2000, 2004, 2008, 2012, 2016. I would guess, kind of following this pattern, is going to be roughly 46.2 seconds. So as long as you're within reason, I mean, if you're somewhere between 46 and 48, that's going to be fine with me. What does that say? Elephants are pregnant for 2 years. Have a great day. There also might be a segment that I have to add on how to find outliers, so just be aware of that.